Is the whiteboard visible? Yes, right? Okay. Yeah. So whiteboard is visible. So what we have discussed in the previous version or the previous class is we were discussing about the even and the odd signal. Let me brush up a little concepts that what we had discussed in the previous class. So it is the even and the odd signal. So what is the condition to be specified for an even signal? X of t will be equal to x of minus t, and x of n will be equal to, yeah, x of minus n. Okay, so these are the conditions what is to be specified for both even signal and the odd signal. I have sent the handouts also. See to it that you go through the handouts. I have explained in detail whatever that concepts when it comes to even and the odd signal. I'm just seeing that the condition is to be there. Okay, this is an odd signal. If I want to write an odd signal, again, what do I do? X of t, that would be equal to minus x of minus t. Okay, so x of t, the original signal, so that is equal to minus x of minus t, that is being there for the odd signal. Okay, so x of minus t will be equal to minus, yeah, 1 minute, 1 minute. Yeah, so I have the signal called as x of minus t, that will be equal to minus x of t. So this is being present. Next, x of t, if I want to write it, minus x of minus t. So here you will observe this minus and the minus associated with respect to the time parameter, again, that is to be expressed. So what needs to be done? First step, you need to change t to minus t. So first step, you need to change t to minus t. Next, what you need to verify? You need to verify whether this signal is having the same values even if it is multiplied by minus 1, the original signal. So let me give you an example of an odd signal right now. So check, you will get a question like this. Check whether the given signal, whether the given signal, check whether the given signal is odd or even, odd or even. So another important parameter or important observation what you can make here is you can decide or you can understand in such a way that once a signal is classified as an odd signal, it cannot be called as an even signal, and if a signal is being called as an even signal, it cannot be called as an odd signal otherwise. So you have signals, generally they're odd in nature, they're even in nature. So there are signals that are neither odd or even. Okay, so they are not categorized either as neither as odd or even there. So that is one thing that you need to get from here. So what you need to observe here when it comes to the signal being called as an odd or even, condition has to be satisfied clearly. So if I want to satisfy the condition here, let me write down this signal here somewhat like this. Okay, so this is a signal and this one is t by 2 and this one is minus t by 2, and the next one what is there here is, so the magnitude what is there, so that is 1 and minus 1. This one is t and this one is generally called as x of t. Okay, the signal what you write here, the first one, it is x of t, that is the sketch of a signal what I have written here, sketch of signal. Yeah, so you will be having certain conditions also being specified for certain signals. So if I have a signal like this, what do I need to do? I need to whether verify it is even or odd. So those who have missed the previous class, see to it that you just go through it. X of 0 equals 0. Next, what you have, x of capital T by 2, that is equal to 1. X of minus t by 2, that is equal to minus 1. Okay, if you see here, this is the value, and otherwise, so all the values are said to be 0. That is not even given in the signal. So this is said to be x of 0, x of t by 2, that is equal to 1, x of minus t by 2, that is equal to minus 1. What I'll be representing here is So let me write down here x of t by 2, that will be equal to 1. So the value of t, this is a small t, this is present here, and this one is the value when t equals capital T by 2, the value of x of capital T by 2 will be equal to 1 here. So this is what you need to understand in the remaining classes or the coming classes which is there. So you need to clearly understand the value of t will be equal to capital T by 2, and its value when given it as capital T by 2, this t, okay, this t, whenever I give it as t by 2 or minus t by 2 or any other values, the magnitude whatever that is taking or the resultant of it will be equal to 1 depending on the problem that I have listed here. Okay, so moving on, these are the values for x of t. Okay, these are the values of x of t. Now what is the first step that you need to do? So you need to change t to minus t. Okay, when you change t to minus t, what you will be getting? X of minus 0. What is x of minus 0? Minus 0 is nothing but 0 there. X of 0 will be equal to 0 depending on the parameter. So whatever the values that I am writing here, this is for x of minus t. Okay, next what you need to do? X of t by 2. Okay, x of t by 2 will be the value. So when you move to the right hand side of the equation, this is the right hand side of the equation, t greater than 0. This here represents t less than 0, and at the origin it is called as t equal to 0. Okay, so x of 0 equal to 0. This is what the condition, what I'm specifying it for x of minus t. So this is x of minus t that is being present here. Here what it represents, x of minus t by 2. Once I put t by 2, so it is x of minus t by 2. So this is t by 2 here, and this one is minus t by 2. So x of minus t by 2, what it represents? It represents minus 1 here. Okay, so next x of minus t by 2. Okay, x of minus t by 2. So this here value represents t. This here the value represents t here. Minus into minus, that would be equal to plus x of capital T by 2. What is the value that is specified? That is 1. Hope you are getting what I'm telling. This is the value that you need to sketch now for x of minus t. X of minus t value, I need to sketch it. Okay, sketch the signal. Sketch the signal for x of minus t, or sketch or write the signal or represent a signal for x of minus t. Okay, how do I need to write it? So at 0, I have 0 x of minus t by 2. Okay, this is nothing but x of minus t by 2. So that is equal to minus 1. This is minus 1 here. This is plus 1. Okay, 1 and minus 1 that is being present here. So I need to write it as minus 1. Okay, next what do I need to do? I need to write it down for plus t by 2. This is for plus t by 2, that is 1 here. Okay, what do I need to do here? I need to draw the signal again, which is for x of minus t. So if you observe this signal, which is x of t, and this one which is for x of minus t, so you are having a value which is being there. So now what you need to do, you need to match the values. Okay, so you need to match the values. Let me rewrite the signal again, x of t and x of minus t here. So this one, what you need to determine here is, you need to determine whether the signal is an odd signal or an even signal. Okay, so x of 0, that is equal to 0 there. X of 0, that is equal to again 0. X of t, what's the value? X of capital T by 2, that is equal to 1 there. X of minus t by 2, that is equal to minus 1. So 1 minus 1. Next, what you need to do? X of t by 2. Okay, so x of t by 2, this is the value here. So what it represents? It represents minus 1 there. Okay, so x of minus t by 2. Okay, x of minus t by 2, so that represents the value t. What it represents, when multiplied with minus sign again, this is the operator, it gives 1. So it is unequal right now. what you need to do, so to verify this signal as an even signal or an odd signal, so it needs to be same, the values needs to be same here. So you need to multiply by -1 to this, multiply -1, okay, multiply -1 to this signal. So what you will be getting for minus x of t, so that is again 0, that is 1 here, okay, let me erase it 1 minute. Yeah, so it is again 1 here, and this one, what is being, what it represents, so this is 1 here again, okay, yeah, this is 1 here, and this one is -1, okay. So all the values are set to be equal once you multiply by -1, minus x of minus t, okay. I repeat, x of t, when it is equal to minus x of minus t, then the signal is said to be an odd signal. Then the signal is said to be an odd signal. It is not an even signal. The signal is said to be an odd signal, okay. So I have checked it, and I can certainly say that this given signal is said to be an odd signal, okay. This given signal is said to be a odd signal, okay. Hope you are getting what I'm telling right now. So you have to first analyze what are the values that are being present there. Next, put those values and get the magnitude of it, or get the resultant or the values once you put t by 2, minus t by 2, and so on. So next, after putting that value, you will be getting these values to be written. Next,
Hello,
change. Yeah.
Sir, can you explain last step, sir?
Yeah. Okay. Well, just a moment. So hope you have understood this one, no?
Yes, sir. Yes, sir.
Okay. Now by changing t to minus t, you have got it. Okay. Yeah, you can unmute yourself. Yeah. So see to it. Once you change the sign, you will have a change in sign here also. This is the t value. Okay. This is the t value. This is minus. This is minus, and minus t by 2. What is the value of minus t by 2? -1 here. Okay. -1 is there. So that is x of minus t by 2. This is for x of minus t. What I'm writing here. So this one, it is x of minus 2. The third one, what I get here is for x of minus 2, that is x of capital T by 2, that is equal to 1. So this is equal to 1 here. Okay. So this value, I have got it for x of minus t. Hope it is clear now. Next, what do I need to do? I need to categorize this signal here. X of 0, that is x of minus t. So that is for 0 here. Now, where did this minus come? Okay, so what do I need to do? I need to verify whether the signal is an odd signal or an even signal. Depending on the values that I've got for x of t and x of minus t, it is not matching. The values are not matching. So once you have got 1 here, you'll getting -1. So only when you multiply with -1 into x of minus t, okay, -1 is nothing but a multiplicating factor. So when it comes to the properties of signals and systems, I'll tell you what do you mean by amplitude scaling. So this is what I have done here for amplitude scaling here. So amplitude scaling here, I have multiplied it by -1. So 1, this is -1 into -1, that is again 1. It is matching. And again, if I do the same for the third one, it will be for 1. That is, you have to see to it that x of t, that will be equal to minus x of minus t. So once I have seen that it is not an even signal, I can generally say that it is an odd signal. Or if the given signal cannot prove itself as an odd signal, it is considered as neither an odd signal nor an even signal. Okay. So given signal here, this signal, what I have written here, is proved to be an odd signal, considering the fact that x of t will be equal to minus x of minus t. Okay. So this is the condition to be verified. So let me write here again. So x of t, okay, x of t will be equal to minus x of minus t. Hope it is clear to you. I hope everyone has got this fundamentals clearly. Even if I take one more class, it's not a problem. So these are the fundamental things that you need to be very clear with. Okay, so given any signal, you have to identify whether it is an odd signal or an even signal. Okay, the same thing holds good for the discrete signal here. So let me take one more example for a discrete signal here. Okay, so for a discrete signal, what is the term that I need to use? I need to use the value called as n. Whether check whether the given signal check whether the given signal check whether the given signal is odd or even. Check whether the given signal is odd or even. What do I need to do? I need to write the signal x of n. Okay, so x of n, what it is, this is the value of n, this is the number of samples that is taking like 1 2 3 or 4. That is the discrete signal there. Only at that instant of time you will be getting the values there. So let me sketch a signal here carefully. I'll sketch a signal. Okay, so this is n and this one is said to be x of n. Okay, so what do I need to do? So this is 0, this is 1, this is 2. So here this is -1, here this is -2. Okay, so at 1 and 2 the magnitude is said to be same. This is 1, this is here. So what do I need to do? I need to write the magnitude as -1. So I mean sorry, +1 here. Here it is -1. Okay, yes. So what do I need to do? So this is -1 here. Yeah, let me show it by dotted line representation. Yeah, okay, so this is 1 here. Okay, 1 and -1. So let me write down x of 0, whether I need to verify whether the given signal is odd or even. Okay, what is the condition for even signal or odd signal? You need to remember it, and then you have to prove it whether it is an odd signal or an even signal. Okay, so x of 0, what's the value here? 0. X of 1, what is the value? That is 1. X of 2, that is equal to 1 here. X of -1, that is equal to -1. X of -2, that is equal to -1. So these are the values that are being listed out. So the n value will be 0, 1, 2 on the right hand side, that is n greater than 0. Okay, and n greater than equal to 0, 0, 1, 2 will come into picture, and this one will be for n less than equal to 0. N will be e -1 and -2. Okay, so this is what you get there from this given data. What do you need to do now? Okay, what you need to do now is you need to change for n to -n. Change n to -n. Okay, change n to -n. What you are going to get? So once you change n to -n, you have to plot a signal for x of -n. So plot x of -n signal. So I'm going to plot it after I write down this signal. So for x of -n, what are the values that are going to get? X of -0. I repeat, this is for n. This is the minus sign that is there. Next, x of -1. Okay, now once I take, this is n equal to 1 here. So let me write down here, n is equal to 0, n equals 1. Okay, n equals 2. What do I need? What do I get? X of -2. Next, n is equal to -1. X of the minus value which is already there, and -1 that I need to write again. Next, n equals -2. X of -2. What do I need to write? I need to write the values of it. So x of 0, that is equal to 0. X of 0, what's the value? That is equal to 0 from the previous thing what I've got there. So next, x of -1. What is the value? -1. That is equal to -1 there. X of -2 is definitely also equal to -1. X of -1. X of +1. X of +2. Okay, x of 1 here, that is equal to 1, and here it is equal to 1 here again. So next, what you need to do? You need to compare. What is the x of n values for x of 0? That is x of 0 is equal to 0. Yeah, it is matched. Okay, now x of 1, x of 2, x of 3, x of 4. Okay, x of 4. What is the value? X of 1, what do I need to get? 1. So here x of 2, what you will get? That is 1. X of 3, sorry, x of minus 1 here, sorry, x of minus 2, what you are going to get? Let me erase it. Yeah, x of minus 1, x of minus 2, what do I get? That is minus 1, minus 2. Okay, so you have got the signal values for both x of n and x of minus n here. So I can see that there is a mismatch in that. So x of n and x of minus n, there is a mismatch, so it is definitely not equal to an even signal. Okay, what do I need to do? I need to multiply x of minus n with respect to minus 1. So I need to multiply by minus 1 to check whether it is an odd signal. Okay, hope I am clear to you right now when it comes to discrete signal. Hello? Hello? Yeah, is it?
Yes, sir.
Okay, okay. Okay. So others, if you don't understand anything, you can unmute yourself and you can see to it that you tell me to repeat it. I'll repeat, not a problem. You tell me to repeat, I'll repeat it from the beginning. It's not a problem. So I want everyone to understand the basics clearly there. Okay. Yeah. So let me plot a signal of x of minus n. Okay. So x of minus n is the signal to be plotted here. So x of minus n, what is x of 0? 0. X of minus 1, minus 1 here. Okay. So yeah. So this one, it is there, and this one, it is quite clear here. Okay. So for n equals 1. Okay. So for n equals 1, it has to be, yeah. So this is for n equals 1 here. Yeah, n equals 1, 2, this one. Yeah, so for n equals 1, n equals minus 1, minus 2. So for n equals 1, what is the value there? N equals 1, that is minus 1, like this. Okay, so for minus 1 and minus 2, you have the values written like this. Okay, so don't get confused. This is n values what I've listed out here. Okay, so this is after putting this n values, what you are going to get here, x of minus n factor. So next, what you are going to do, this is 1 here and this is minus 1. So next, what you need to do, you need to multiply by minus 1, x of minus n. Okay, minus x of minus n. Okay, so what you need to do, once you multiply these values, you will be getting the original signal like this. Okay, so this is original signal, so which is 1, 2, minus 1, minus 2, and again you are having this to be equal to 0. The value of 0 is nothing but x of 0 will be equal to 0 again. Okay, so see to it that you understand certain problems very clearly. If you have any doubts, let me know, because these are the fundamentals, and once we go with the properties of signals and systems, it is quite difficult for you to brush up with the basics if you are not clear with it. So there you will be having amplitude scaling, time reversal, time shifting, many properties will be there, and those properties will be carried out. Each and every module is interlinked in this signals and systems fundamentals course, and see to it that you get a better understanding of it. Okay, so this is what you can get here, and what you can write here is x of n will be equal to minus x of minus n. So this is the condition to be verified for a odd signal. Okay, so it is not an even signal, it is an odd signal. So I can say that the signal is said to be what is it? It's an odd signal. Signal is said to be a odd signal. The given x of n signal is a odd signal. Okay, it is verified with respect to x of n, that will be equal to minus x of minus n. It is called as a odd signal. Okay, so that is the thing, or that is the concept that is being shared here. Okay, so what you need to do now is you need to have a signal where you will be having both even components and also the odd components. We generally call that to be the decomposition of a signal. Okay, decomposition of signal. Okay, so decomposition of signal. So what you need to write here is, so you need to write a signal where it contains the even component of it and also the odd component of it. So x of t, that will be equal to x even of t and x odd of t. So this one is the even part of the signal, even part of the signal, even part of signal. Next one, it's said to be a odd part of the signal, odd part of the signal, okay, of the signal x of t, of the signal x of t, of x of t. Okay, so even part of the signal. So even signal, generally even part of the signal, which is the original signal is x of t. So I can write the decomposition value or a decomposed value. So once it contains both the even signal and also the odd signal, I can write it like this. So even part of a signal x of t and odd part of the signal x of t that is being present here. Okay, so now what you need to do now is you need to find out the relation between even signal in terms of the original signal and also the values. Once you put the negative values there, so what's the equations that are being associated with it. Okay, so what you need to do now is step one, you need to write the value, change t to minus t there, change t to minus t, what you are going to get in the above equation. So this equation is called as equation 1. So x of t, once you change it to x of minus t, what you are going to get, so once you change t to minus t here, okay, so what you are going to get, you are going to get, okay, let me write it again. So x of minus t, x of minus t, x even of, yeah, let me change it as minus t plus x naught of minus t again. Okay, so this is what you get by changing t to minus t. This is the first step that is there, so which is equation 2. Okay, now what you need to do now is you need to recall the condition for an even signal, for an even signal, for an even signal, x even of minus t will be equal to x even of t. If you recall the fundamentals of signals, what we did in the previous class and today at the beginning of the class, for an even signal, x even of t will be equal to x even of minus t there. Okay, so this is what you will be getting for x even of t will be equal to x even of minus t. So let me replace here with respect to minus t signal, that is x even of minus t will be equal to x even of t. Next, the odd signal, x naught of minus t will be equal to minus x naught t. Okay, so this one is for a odd signal, for an odd signal, for an odd signal. Okay, so minus x naught of t. So this is what you get there for the third equation after verifying the conditions for both even signal and the odd signal. Okay, so this is what you need to remember. The first equation, the second equation is changing from t to minus t, and the third equation, what you get there after the condition is being verified here. So let me go to the next page now. So let me write equation 1 and 3 again. So x even of t plus x naught of t, and the third equation, this was for equation 1, and x of minus t. Next, what I can write, x even of t minus x naught of t. So after the conditions, after the conditions is verified, after the conditions are verified, sorry, after the conditions are verified, I can write the even component and the odd component. This one is even and this one is odd. Okay, so now what do I need to do? I need to find out the expression for the even component of this signal. So what do I need to do? So adding equations 1 and 3, adding equations 1 and 3. Next one, I need the odd component. What do I need to do? I need to subtract the equations 1 and 3. Subtract equations, subtract equations 1 and 3. Subtract equations 1 and 3. So what do I need to do? So if I add equations 1 and 3, I'll write it directly here. So what do I get? This is minus sign here. Don't get confused. So this is 2 times xe of t. So I'll be adding x of t plus x of minus t there. Yeah, let me write down here x of minus t. Okay, so next xe1 of t, that would be equal to x of t plus x of minus t divided by 2, or I can write it in such a way that xe1 of t will be equal to half of the value, that is x of t plus x of minus t. Okay, so this is for an even signal. Given a signal, so find out its even component. So you can find out the even component with the equation listed down in equation 4 here. Okay, so next, what do I need to do? I need to subtract equations 1 and 3. So what do I need to do? X of t minus x of minus t. What do I get? So subtracting, so even components get subtracted, so I'm only left out with the odd component. So that is 2 times x naught of t. So x naught of t can be given as half of x of t minus x of minus t there. Okay, so this is one thing that you need to be clear upon. The odd component x of t, x naught of t, that would be equal to half of x of t minus x of minus t there. Okay, so this is what you mean by the odd component of the signal x of t. So let me summarize here. So x of t can be written as, yeah, the even component of it, x even of t, can be written as half of x of t plus x of minus t. Okay, so next one, what you are having is the odd component of the signal, that is x of t, again half of x of t minus x of minus t. So these are the components that are being present there in the signal. So this is the even component, and this one is the odd component here. Okay, so we will stop here, and in the next class we are going to solve a few more problems related to even component and the odd component. So I'll send the list of problems. Try to copy down the list of problems, and we are going to have the solutions being done directly. So if there are any doubts, if you can unmute yourself and you can let me know. If there are any doubts what we have done in today's class or the previous two classes what we have done, you can let me know. You can unmute yourself and you can let me know. If there are any doubts, you can reach out to me. I'll be available. You see to it that you solve more number of problems as class proceeds. Try to see that you get the fundamentals clearly done. Okay. Thank you, everyone.